Hey everybody, it's Dustin over at Geekmatics, and today we have an iPad Pro 12.9 second generation. Now, the issue with this device is it has no touch after a screen replacement. I have a feeling that what happened here is that the battery was not disconnected when they attempted to attach the new screen to the board, which what will happen there is when you have voltage at the connector and it's not aligned 100% correctly and you just a little bit off, you'll have a power rail, normally for touch or backlight, that goes to ground, and then all of that voltage going to ground, and it will normally blow a filter. One last thing I wanted to bring to your guys' attention before I dive into this repair is that we will be looking at ZXW today, but ZXW is very limited on what it has versus some of the older models. So I'm going to be going to the Wiki page. I'll link the description in the below. It has a ton of information, a ton of diode mode measurements that ZXW does not have, along with NAND compatibility and a ton of stuff for MacBooks as well. If you guys are trying to get into MacBook repair, there's a good place of information. All right, so let's go ahead and get started. Alright, so as always, we're going to do a visual inspection. Now, what we are going to be visually inspecting, we're not going to be doing the entire board like in a case of liquid damage or a no power situation. We're going to be looking towards the bottom of the board where, you know, the connector is and all of the filters and everything. So let's look here. Before I even take off, and I just want to make sure you guys can see clearly, before I even take off the black cover here, you can see, look, this got very hot. It melted right through the black covering, and also right here as well, the same thing. So we are going to look at those, all right, as well. Now, that's about the end. I mean, over here you see maybe some heat over here, not really too much like here, but we're going to do diode mode at the connector and look at ZXW. So even if we didn't have that visual hint, we would still find what. All right, so let's go ahead and pull up our Wiki page. Make this bigger for everybody. So what I use is the logiwiki.shinycomputers.com. That is the wiki page if you ever hear me refer to it. And again, the link will be in the description. And you'll see all of the different pages they have here, all of the different type of information they have here. A lot of it's MacBook, some of it's iPhone. You have backlight troubleshooting, compatible schematics and diode mode measurements, NAND compatibility, iPhone, iPad, TriStar compatibility, an iPhone, iPad component list. So let's go ahead and write in what we're looking for, which is iPad diode mode measurements, okay? And this is the iPad Pro 12.9 second generation, so we'll jump down there. And then we have these two images, it looks like, for diode mode measurements. So what I'm going to do is I'm going to record myself taking all of the measurements, and then I'm going to go back and listen to myself take those measurements and compare them to what we have here to make sure everything is good. And what's good about these pictures is you can actually see the components on the board and what they're supposed to look like, and you can kind of compare it to what you have. All right? All right, guys, so I'm going to go ahead and start taking these measurements. Now what I'm going to do here is I'm going to have red probe on ground. Let me get that effect away from you guys. Sorry about that. So I'm going to have red probe on ground, and then I'm going to be probing and taking the measurements with my black probe. Now I am going to go ahead and be in diode mode. I can't see my cameras, but I assume you guys can see it's the white one there, okay? And just to double check that that's back in focus. Yes it is. Okay, cool. So I'm going to read them out and you guys will be able to see. I'm not going to be able to see the measurements. I'm just going to run through them, and so you will see the mistake, but I won't right away until I play it back. That's how I normally do it, so I don't have to keep moving my head back and forth. All right, so we have ground, 393, 712, 357. I've got a glare, so I can't see it easily. 391, 391. Seven, 547, 547, 551, 671, ground, 605, OL, 284, 282, 284, 612, 289, 285, 605, ground, 632, ground, 391, 417, 391, 391, ground, 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 and at the top we have ground again. So my next step here is to go ahead and listen to myself and actually look at this picture like you guys just did. You guys already saw the differences. I didn't see the differences. I wasn't looking at the picture. So now I'm going to go ahead and pause this and listen to it and find the issue myself. All right? Okay guys, so before I go back and actually listen to myself and take comparisons to what I should have and what I do have, I do want to describe the two things that we would expect, okay? The first thing is an OL, or an open line, where we would expect a measurement, and what that's going to be is a filter or a fuse that has been blown, which means it doesn't have any continuity between each side of it, okay? Another thing I would expect is a ground measurement, where I expect something else, and that would indicate a short. Now, I don't think that's going to be the issue in this case, because I believe the short happened from when they were trying to connect the screen with the battery connected, so the short would have been essentially the screen connector touching something it shouldn't have, okay? So that's why I believe it's going to be an OL. So I will go ahead and double check and make sure. Alright guys, so I just took a look at it in the video, and it looks like it is the second connector, the 7th pin from the bottom right, that's giving us the issue. So let's go ahead and confirm. Okay. Line ground again, so 1, 2, 3, 4, 5, 6, 7. What? And we have a reading there. So the next thing we're going to do, let's look at ZXW and see what ZXW says about that pin. Okay, so now that we have ZXW open here, let's go ahead and figure out. I think this iPad may be trolling us, but I'm about to show you what happens what I do when an iPad starts to troll me. So we got 1, 2, 3, 4, 5, 6, 7. That's this one here. Now this is the very limited information I'm talking about, where it doesn't have any names or anything like that. It just has dots to show you that they connect, okay? So it looks like those two lines connect over here and then go through. Maybe this is a filter, I'm not entirely sure. And the rest of the connector looked okay. This one up here was a little high, but I don't think that has anything to do with touch. So it may, I don't know for sure. I don't have schematics. So what we'll do is we're going to go ahead and finally we are going to take that black cover off and see what it looks like underneath. Look for another set of tweezers other than my favorite tweezers to do that. Okay, so this is what we see here. Put that somewhere else. If we zoom in right here, we see this piece that looks no bueno, no good at all. Okay, this one here and this one here as well. Now I'm assuming those are filters, okay, and that's got crud all over the top of it. And what we'll do is we're going to measure in diode mode or continuity mode to see if we have continuity between the two. All right, if I can just find my other probe. All right guys, found my other probe. So what we're going to do is we're going to see if these two have continuity between them, and they do. All right, and that's trolling right there. That I would not expect it to have the continuity that it does. Okay, I didn't have a good measurement at the connector, and it's physically burnt. So what I'm going to do, just to stop myself from getting trolled by intermittent issues, I'm going to go ahead and replace that anyway. All right, and also let's make sure we have continuity between this side and the connector. We do. Perfect. And now the next two lines that seemed like I got an okay reading on is connected to this burnt filter as well. But let's go ahead and confirm with ZXW. So you can kind of see where we're at there and see. So this is the pin that we're having issues on. I believe it was this one here. Yes, that's also connected to that one and through what looks like a filter. And then the next set as well also goes through a filter. Okay, now they are showing continuity between it right now, but I am still going to go ahead and replace them to make sure they are okay. All right, guys, now you may ask, how do I know that that's a filter there versus a capacitor? That's a good question. What I would say is if we jump to ZXW, normally a capacitor will have at least one leg on ground like these do over here. You see one leg is on ground here. Now, as well as this one, it has a leg that goes somewhere else. So normally what you see there is either a resistor or a filter type fuse mostly, and if it's a resistor, it looks a little different than that. So we can assume that it is going to be a filter. Now you're also going to ask, hey, how do you know where to get the part? That is going to be just because you see it on Facebook, join the groups, you know, Micro Soldering for Beginners, Micro Soldering for Academy, and so on, that people actually post about it and say, hey, I had this issue, and you know, these are what you need to change, and they have really great images to show you what you need to put there. Okay, so I'm going to go with the iPhone 6s backlight filter on these, and that's because that's just what I've been told works really well, and it has for me. So we'll go ahead and get to that next. Okay, guys, so I've got to cut a few things here because OBS decides to make audio quality sound like crap, very staticky randomly. So I'm going to cut out a few clips here. I'm sorry about that. I'm only going to keep what's important and do a voiceover on them. Okay, so here we go. Now you'll see I use heat sinks on the iPad batteries just because I want to be safe here. I don't want to, you know, blow up the battery. I haven't seen one blow up, but, you know, I like to be safe. Now, you'll see here, as soon as I go, you'll see a little 6S backlight filter fly away. As soon as I put hot air on the board, went there, I forgot to move it, so we'll have to get another one. And we are with our hot air right now. You see how I'm kind of very slightly nudging it, waiting for it to come loose. I'm not pulling on it, I'm not yanking on it, I'm being very gentle. I'm just kind of waiting for it to nudge free, okay? All right, there's that one. Now we'll go ahead and go right in for our next one while the board's still hot. Get off of there. Perfect. And that one's broken free. And now, since we've lost our 6S backlight filter, we will have to go get some more. All right, we'll go ahead and put a little bit of flux on the board. Smear it around a little bit. Grab our solder. Turn on our iron. All right, now we have fluffy pillows on each side. That's good. We're going to do the same thing for both. A little bit more solder there. Oop, bridge. Okay, that's not good. So what we're going to do here is we're going to add a little bit of wick. We're going to get just a little bit of wick, just enough to soak up that. I'm being stubborn. I don't want to use wick. I'm trying to just dry my iron, but I've given up. So now we come with the wick. Still bridged. May need to look. Maybe we've got it. More flux will always solve our situation. There we go. We are good with that. Okay. Now we'll get our 6S backlight filter. Now, I'm not going to use hot air for these. I'm just going to use my micro pencil and make sure they're connected on each side. Just like that. That doesn't look 100% even to me. I'm going to zoom in and focus. Yeah, looks close enough. Now we'll grab our other one. and I've lost it touching the antenna. So I think maybe I found it now. All right, there she is. We'll go do the same process as we did the last time, just with our micro pencil, nudging each side of it. That one doesn't look okay to me. That one is going to need to be more even. And I'm going to come with hot air just to make these, hopefully a little bit of surface tension will even that one up. Don't forget the battery heat sinks. And just kind of nudge it over a little bit, and we'll do the same thing to this other one. Again, these are entirely too small for what's supposed to be there, but should have the same effect as the big ones. Beautiful. Except for that piece right there. That's not beautiful. All right, so now we're going to go ahead and test here. This is with the client's screen. And we have Apple logo. That's what we always like to see after we put hot air onto a logic board. All right, do we have touch? No, we do not. So now, what I am discovering is the back of the screen is getting very, very hot. And almost, you can't even touch it. And now I'm going to show you the piece that's getting hot. That piece there, the daughter board, is getting hot. So now we'll disconnect the battery, disconnect the iPad screen, and go ahead and take a look at the screen. So I am by no means a screen refurbisher, but we're going to kind of dig into this and see if we can see maybe just a quick short without voiding the screen's warranty, because the client will want to send the screen back if it's the screen. So we'll remove these ribbons. Disconnect the home button. Looks like it's connected there somehow. Never taken one of these ribbons off, so I just want to be careful that I'm not tearing anything. That's why I'm going a little slower, kind of looking to see if there's anything else connected that I need to disconnect before I take this ribbon off. And again, that's something I recommend. If this is the first time you're ever taking apart a device, don't just start taking things off. Look at kind of every angle that you can and see if there's anything that, that's connected that needs to be disconnected. And right now I'm just kind of figuring out, am I going to be able to take these shields off without having to apply hot air onto the screen? Because if that's the case, I'm not going to remove the shield at all. I'm just going to give it back to the client. Again, I do not want to void any kind of warranty that the screen may have. All right, let's go ahead and remove this sticker next and see what's underneath there. See if anything's underneath there.
Look at it underneath the microscope. Ooh, look at this. You have a filter, it looks like, where a MOSFET is supposed to go. What in the world? And the burnt components near it, you see these components look burnt to a crisp. Yeah, there's more than likely a short on this daughter board somewhere causing it not to work with the amount of heat that it's getting. But again, I'd have to remove the shields. I'm not going to remove the shields. I'm going to send this screen back so they can go over their warranty.
All right, guys, so I just got the iPad Pro 12.9 second gen screen in, or known good screen, and we're going to go ahead and test it here and make sure everything is working. Spoiler, I already did it. One day, I'll have a video where I don't have to cut out every 5 minutes, and the reason for that, because OBS likes to make my audio sound bad randomly. So here we go. You can see that touch is working now. Don't want to go too high up and show his name, but touch is working properly. I did actually test the entire screen. How I do that is drag an app going back and forth all across the screen to make sure it's working right, and that did. So we're going to go ahead and call this. Alright guys, so just to review what we did today, we had an iPad Pro 12.9 second gen shipped in with no touch. He said the battery may not have been disconnected when he did the repair. I can say it more than likely wasn't disconnected from the damage. Now, you'll see there that ZXW, or you'll see in this video, ZXW did not have schematics or did not have board views for this device. So what I did to find out what components were there, I actually just reached out to Facebook. That is a vital tool to have. You have a lot of people there that have done these repairs 100 times already and know exactly what components are where. So if you're ever lost or you're confused, I find that Facebook is the best place to go to get the answer. All right, so again, I hope you guys enjoyed the video and I taught you something.